Georefrencing transforms the raw data from the LiDAR, providing range and bearing angles, as well as IMU data, providing altitude and positioning data to point cloud and associated data. With the specifications of the raw data, Microdrones produces a georeferenced point cloud, including all associated data to the point cloud. The point cloud is not only a collection of data, it also contains the uncertainty levels of each point, and a copy of the raw data in such a way that denoising and calibration tools can be used.
Today we'll be using the MD LiDAR 1000. If you click on the drop-down menu, it will give you an option of the different payloads, ranging from the 3000 to the DL to the LR. So we'll be using the MD LiDAR 1000. Next, you will input the LiDAR raw data, which was taken from the flight. In the configuration, we can see that we can input the boresight angles such as the roll, the pitch, and the yaw. Now once you've done your flight, the software will come with its own calibration report, which is saved into the same folder as the data. So the first thing we'll input would be the boresight angles. Now at the bottom of the report, you can see you will input the numbers corresponding to the boresight angles into the software. Next, you will input the lever arms. An important thing to note is that when you're inputting the lever arms, you will always have to use the reference to laser. In the report, you will see 3 different kinds of values that you can input, but you will always use the one at the bottom, the reference IMU to laser, and then you will input the values accordingly. When the configuration has been finished, you click Next. You will then select the destination folder, and this is where you want your files to be saved after the process has been completed. You select that folder. Next, you select the field of view, depending on the project that you do. We will be selecting the 60 degrees field of view for today. You can also select the file type. You're given 2 options. You can save it as an ASPRS LAS file, or you can save it as an ASCII file. So we will save it as an LAS file. There's also an option to export all of your files into one. Now the next step will be to input the output coordinate system. Now for the output coordinate system, you can select whichever datum, the epoch, the projection, and the zone. Now the output coordinate system can vary depending on where you actually flew the drone. Next will be to change the vertical coordinate system. You have the option to choose between ellipsoidal or orthometric. If you choose orthometric, it can give you the choices of the geoid. Now the third step will show you a basic summary of all of the processes that you input. It shows you the product that's been selected, it gives you the input, as well as your trajectory. It also shows you the output that's selected. If you're satisfied with the status of everything that you input, you click Process. Now because we saved it as a LAS file, we can view them in any LAS file reader.